Good morning. In this presentation, I'm going to demonstrate how Juniper QFX5100 switch work with VMware NSX multi-hypervisor controller to provide an integrated network virtualization solution via VXLAN technology. There are multiple Juniper product families support VXLAN technology and can be integrated with NSX controllers. Today, I will focus on Juniper QFX5100. In the next session, I will cover Juniper EX9200 and MX switches with NSX integration. So let's go straight to the demo topology. There's two key points for this demonstration. The virtual overlay network is provisioned by NSX via OVS DB. QFX5100 is a VXLAN gateway to enable the communication between virtual and physical network. So in this topology, your data center already has some virtualized compute and network resource. For example, the virtual machines on Ubuntu KVM or ESXi hypervisors. There are also some legacy physical servers or bare metal servers, BMS. We're going to use BMS or physical servers interchangeable through these presentations. So these physical servers is there because they had been there before, or it could simply be a physical appliance. Whatever the reason, we want to make sure the networking device on physical network can still communicate with a virtualized network resource. In the meantime, your business is growing and the data center is expanding, so you added additional servers, virtual and physical. On different IP subnet, you can build a virtual overlay network on top of the layer 3 physical network. This can be done with an NSX controller with VXLAN technology, like the communication tunnel showing on the slides. Juniper QFX5100, EX9200, and MX switches are the underlying physical networking device to actually move the data package between the servers or applications. More important, Juniper switches are also used as a VXLAN gateway to enable the communications between virtual and physical, like the communication tunnel showing on the slides. The VMware NSX provides a centralized control and management plan for VXLAN-based network virtualization solution. So we can start with the NSX Manager. So now we're logged into the NSX Manager. NSX Manager is a web-based graphic user interface to communicate with NSX controller for initial system setup, configuration, manage, and troubleshooting. The NSX controller manages the edge switching component of the NSX-controlled virtualized network domain. So on the right up corner, that's where you can configure the physical network component. For example, here is the gateways, the hypervisors, service node, zones, and gateway service. Then on the left up corner, that's where you can configure the logical network component. So you have the logical switch, the logical switch ports, the routers, the router ports. You can configure queues, ACLs, security profiles. Then here you can see the hypervisor software version summary. So we have the hypervisor registered in the NSX domain, and here it shows the hypervisor versions. And this box shows the NSX appliance and software version. So typically, the controller runs on the x86 servers in a redundant cluster configurations. As you can see here, we actually use 3 nodes to form a 3-node cluster. Today, we use NSX Manager to interact with NSX controller. But the NSX controller can also respond to the API calls from cloud management platform to provision the virtualized network. So we can go back to take a closer look at this gateways and hypervisors, the logical switch component. So there's 2 gateways registered in the NSX domain. We click those 2 gateways. Those 2 gateways are QFX5100-1 and -2, used as VXLAN layer 2 gateways. And we go back to the dashboard. When we check the hypervisors, we can see we have 2 hypervisors registered in the NSX domain. There are server 3 and server 5. We're going to use that in the next steps demo. We go back to the dashboard. Now look at the gateway service. In the gateway service, we can see what kind of interface attached to gateway. So here we have 5 VTAP layer 2 gateway service attached to the NSX domain. So now we're going to look at the logical switch component. We defined only one logical switch. So in this one logical switch, it has UUID defined its identity. The last 4 number is a DF5D. We can check later on the switch. And then we go back to the dashboard, just look at the logical switch port. We click this logical switch port. So we have 6 logical switch ports attached to this logical switch LS-1. The first 2 logical switch ports attached to the virtual machine on server 3 and server 5. If you recall, we have server 3 and server 5 registered in the NSX domain as a hypervisor. And also we have 4 layer 2 VTAP gateway service attached as a logical switch port. So let's go back to the dashboard. So now we have the basic background on why we do this and what's the major component of the solution and what the topology look like. We're going to start our data packet test. Let's just take a look at the topology again. So we have 2 physical servers, server 1 and server 4. We need to set up the communication between them through the VXLAN tunnel. So they are connected to QFX5100, which are registered as a VXLAN layer 2 gateway in SS controller. So we SSH to QFX5100-1. This is the first VXLAN layer 2 gateway in the topology. We can use a show OSDB controller to check the communication between the SS controller. The controller connection status are up. This switch is connected to all 3 nodes within the cluster. Another command we can use is show OSDB MAC to tell us how the MAC address is mapping to the VTAP address. Another useful command we can use is show OSDB virtual tunnel endpoint. It tells us how many VTAP has been learned on the switch and what's the number of the MAC address on each VTAP. There are many other useful commands. We don't have time to go through every single one of them. You can use show OSDB question mark just to get different options. But what's the required configuration on the switch to make this happen, to make the VXLAN working? Simple. You just need to define the controller address. The interface needs to be managed by OSDB and set the switch option as OSDB managed, then you are set. For this, set VLANs, the long UUID VXLAN OSDB manage. This is automatically generated by the switch, by the Juno software itself, after it learned the UUID of the logical switch from NSX controller. So you don't need manually to put it in. So that's it. That's all the configuration you needed for the QFX5100 to work with NSX controller. And also remember, because in this case, the VXLAN is provisioned by NSX via OVSDB protocol, so you don't need any multicast configuration in underlying IP network. So the configuration is done. Now we can check the data packet forwarding. So we go to server 1. So this is a server 1. So we check the IP address on the server 1. It's a 192.85.1.80. Then we go to server 4. The server 4, we check the IP address on the server 4. The server 4 is 192.85.1.81. So now let's just pin. All right, it's working. So it's a two-way communication. Server 1 able to pin server 4, and the server 4 able to pin server 1. The Ether1 interface of the server 1 and the server 4 are in same logical switch. So we're going to go back to the underlay network to check this address space 192.85.1 is not showing up on the underlay IP network. See, this overlay network address 192.85 is not showing in the underlay network. So next, we will take a look at the VM to VM communications. So we VNC to 2 servers, server 3 and server 5. Server 3 and server 5 are connected to different QFX5100 switches, QFX5100-1 and QFX5100-2, which are separated by the layer 3 network. Server 3 is a Ubuntu server with KVM and OVS installed. It hosts the VM S3v1. Similarly, server 5 hosts another VM S5v1. So those 2 VMs, S3v1 and S5v1, hosted by 2 different hypervisors separated by a layer 3 network. But their IP address are in the same subnet. Those 2 VMs are registered in the same logical switch. Their layer 2 adjacency is established by the VXLAN tunnel built by an NSX controller. So first, we just want to show the underlay IP network use totally different address space. So on the server 3, we use a 5.3.1 address space. On the server 5, we use a 5.5.1 address space. Again, on the virtual machines, we use a 192.85.1 address space. And secondly, we want to check the OVS is successfully installed on the hypervisor and the VM is running. We can use the server 3 as an example. We can use the virg-c QEMU system list command. So we have one VM S3 V1 is running. So by the way, virg is a very useful command. We can use it to create a VM, delete a VM, and start, stop a VM. We also want to check the OVS is installed and working, and is managed by the NSX. So as you can see, the OVS is talked to 3 access controllers, it's talked to 3 remote VTAPs, and VTAP 5513, VTAP 1.0.0.1, and VTAP 1.0.0.2. By the way, which are the VTAP of the QFX5100-1, QFX5100-2, and the VTAP address of the server 5. So all these VTAPs are managed at the VXLAN interface. And the physical interface Ethernet 1 is managed by OVS for the external communications. Alright, so let's go back to the virtual machines. We want to do a SSH from server S5v1 to S3v1. Alright, we're in. Excellent. So now we're in S3v1, which is SSH from S5v1 to S3v1. While the communication between 2 VMs and the 2 VTAPs are happening, we just want to go back to the hypervisor to check the flow table in the OVS database. So what we can do here is to use the OVS dpctl command. So now in this flow table, you can see the data flow is from source VTAP 5.3.1.3 to destination VTAP 5.5.1.3. Protocol is UDP, TOS is 0, and TTL64, fragmentation is no. And then on the reverse flow, the VTAP source is 5.5.1.3, and destination VTAP is 5.3.1.3. So alright, so far we have demonstrated physical server to physical server, VM to VM, all through the VXLAN tunnel. So next we're going to do a fully meshed pin from VM to physical server, from VM to VM, and from physical server to VM as well. So we can start from VM S3v1. So first we're going to pin the VM S5v1. So we pin 192.85.1.50, which is VM S5 v1, it works. So now we're going to pin the physical server 1, 192.85.1.80. It works. Now we're going to pin the 81, which is physical server 4. It also works. So now we go back to the physical server 1 and physical server 4. From there we can pin this virtual machines. So on the screen, those two physical servers are still pinning each other. We're going to stop it, and instead of pin from server 1 to server 4, we're going to pin the VM S3 v1. It works. So to just recap what we have demonstrated, we have demonstrated virtual machine to virtual machine, physical server to physical server, and physical server to virtual machine to physical server, all through the VXLAN tunnel. The VMware NSX controller provides a centralized control and management plan for the VXLAN technology. And Juniper QFX5100 switch provides the underlay layer 3 IP network, and more important, it provides the VXLAN layer 2 gateway functions to enable the communications between virtual and physical. In next session, we will show how Juniper EX9200 and MX can bring additional VXLAN functionalities. So this concludes our demonstration today. Thank you for your time.